Planning for the power system has evolved from a basic summer camp archery program to instead feel more like a Hunger Games scenario where we are trying to hit a moving target from a moving platform. What do I mean by that? As we sit comfortably in an air-conditioned hotel on a hot and humid summer day in Washington, D.C., during a summer where we have experienced the hottest days ever recorded on Earth, let's think through what it takes to get through yet another record-breaking heat wave hitting next week, next year, or even next decade. Seeing a weather forecast for 3 days in a row of 100-degree temperatures means that we'll all have our air conditioners running all day and all night. If the heat wave hits up in Boston, where I live, some folks still don't own air conditioners. Many will run out to buy window units, as I did. And if this happens again next summer, I will probably be calling all the local HVAC companies to see about getting central air installed. But that's just people like us, who have the means to adapt relatively quickly to changing extremes. Others won't be so fortunate and will suffer from uncomfortable and even dangerous indoor air temperatures, forcing our society to reckon with how we deal with heat. Looking beyond the impacts to people, however, let's stop and think about what it means for the power system to get through a heat wave. Fossil fuel units become less efficient when the temperatures get really high, and any subsequent warming of water used for cooling can cause further constraints on generation. Adding to that, transmission and distribution lines can't carry as much load. So do we simply install more capacity all around? How much? And how do we align this with our decarbonization goals? Thinking about that capacity question, there are also changing technologies at play. With recent advances and incentives, a lot of customers will be switching from air conditioners to heat pumps for cooling. This is great because they are more efficient. But will demand actually go down? Maybe not, as temperatures continue to rise and as homes without any cooling at all install heat pumps. Better building insulation and energy efficiency will help some, but there's also the potential for huge new loads to come onto the system. Think onshoring of factories, desalinization, increases in cryptocurrency activity. How do we account for these changes, and how certain are we of the outlook for the future? Okay, let's assume we figure out the capacity question. In a perfect world, we just install enough to make sure that we can meet those demands on a hot summer day. But because much of this capacity will be solar and wind, we also install batteries to enable us to manage the variability. But since my hypothetical heat wave is projected to last for 3 days, will this battery capacity be sufficient? What if we also end up in a cloudy, low wind period across a large swath of the country? Are we able to rely on neighboring regions to send power where it's needed? The risks of not having enough electricity to go around are real and are likely to grow if we don't account for the complexities involved in grid planning. If we end up in the unwelcome situation of not having enough power to go around, then what? Some people don't have electricity in the middle of a heat wave. Who decides where the power stays on? How do we even begin to prioritize essential services versus equity and health concerns? Can we better plan for the possibility of needing to make these determinations in the first place? There are likely benefits to robust collaboration between communities and power systems to alleviate bad outcomes through community solutions like cooling centers and local outreach, but this takes work, often beyond what is standard today. As I've hopefully laid out here, the nexus of climate change, decarbonization, and electrification adds complexity on top of what is already a very intricate problem of balancing supply and demand across the grid. And this is a challenge that the energy sector is faced with. Ensuring a reliable and resilient grid while the risks around us change is a fast-moving target. And we are aiming to hit that target from a moving platform as the grid itself evolves. The summer of 2023 has shown us that hotter and longer events are here. The consequences of being unprepared are severe. Luckily, even as we stand on a moving platform, we already know which direction to aim our arrow towards. For example, low carbon technologies, demand response, and proactive adaptation to climate change all have us heading in the right direction. There are countless brilliant individuals, including those that we at EPRI work with across a wide range of research projects tackling these issues. who are holding the bows and arrows, invested in moving us in the right direction. And I encourage you all to embrace the challenge of trying to hit that moving target. Thank you.